Yes. YouTube. Oh, yes. That's one. Stephen 8. Jetzt ist von Stehen statt. So I'm going there. For them. So be this. Right in look for him. Oh, you have to see this fine count. Fine to fine to this one. It's already new, I think. Yes. What's the okay. So you have to look for this first. That will be fine. Yes. Import a new thing. Search. Solid liquid. To have even. What's the reason why this is not? It's iCloud. Level 3. Right. Go to the iCloud. Drive here. Right. Use this one. Yes. Whoa. Where is the where? Yeah. Then from the we oh, yes, yeah, here. Of mine, I've had 5. I said yes, in you just over. What this one? What time now? It's 28. Let's see. This one is so. This before is one, right? Yes. Yes. No. Right. Back. Why? These one. And it should be right here. It's M605. Yes. Yep. That's it. Oh yes. This is on this right. Oh, yeah. You go to the and let's manage or I think this one's over. Yes, not entertainment, it's education. It's education with it's no problem. Here, need to go live in stop. This one is very small, right? So small. So use this. Exit stream and look at this, right? It's not made for it. It's the right here. Open it. Oh no, this one. Stream. Okay. Yes. Oh, how it? Okay. Yes. Good morning, everybody. Welcome you to SCI33206. Right. And yes. We're gonna go ahead immediately. Yes, I hope that you can see everything, right? I'm gonna stop so that the quality here is quite great. Here. Yes, we will talk about I hope the sound and so on would work perfectly. Let me check whether the sound is okay or not. Test 1, 2, 3. Test 1, 2, 3. Right. 1, 2, 3. Okay. Yes. เสียงใช้ได้นะครับคุณเลือกดูเอานะครับคุณเลือกดูเอาYes. All right. Okay. ก็ยังไงนะถ้าส่งลิงก์ให้เหรอก็ it's going to be something like this. Firefox, where is that? This one. Firefox. So where is that? Firefox. So please. Firefox. Okay. All right. Right there. Why? Okay. Yes. We talk about the second question, right? In that example, as I can remember properly. We reached almost quite at the end of this chapter, right? We have to practice more, right? In yes, we live at page 126. Okay, 126 in this one too. Right. That's the second case, the second situation, right? When our state has been completely pulled up, okay, from the water, and now it's stay above the sea level, right? Sea water level. And yes, then they asked us to look for, I don't completely understand what the lecture note may not be. Sharp and lecture note iPad. Yeah, it's already 190. Okay. ภาพชัดไหมครับถ้าไม่ชัดก็แจ้งได้นะครับประภาวิทย์มาแล้วคนแรกครับโอเคanybody else okay sorry ชัยสิทธิ์นะครับเพิ่งเห็นนะครับ and some anybody anyone more who wanna attend okay yes that's the oh I didn't share the screen, right? I'm sorry for that. Zoom. We need to share the screen, right? Okay, all right. In yes, right here. Right? Sorry for that. I didn't share the screen. All right. Okay. Yes, the one we will talk is the second situation when the statue is completely out of the water, right? We were trying to pull it up last time, right? And yes, we have got some information, right? The tension in the previous situation, right? Which involves the buoyant force, right? And it's denoted by FV here, right? In for the last case, now the statue, let's draw the free body diagram, right? It's right here, it's a mass M, right, which represents the statue with mass M, and we have a force right here. Let's say it's in blue. Okay, it's the tension in the second situation, and of course there will be mass W, right, which is mg in this scenario. Let's say this is the plus convention. So we will you would see that yes, you would see that I don't understand. Okay, you would see that T2 will be positive, right? T2 will be positive, and W is going to be negative, right? It's going to be negative. So okay, let me look for the YouTube link. Okay, sign in. The so, and look at the channel, try to send the link to you, right? This thing, yes, this one, right? To you, M604, right? And right here, you have another link for M604, right? and this one too, right? Okay, 3 links have been sent to you, right? Okay, yes. Next, okay, ประภาวิทย์อยู่ที่อันนี้นะครับมีนักพัฒน์มานะครับแล้วก็2 คนดูที่นั่นนะครับมีประธานินด้วยเข้านะครับมีใครจะเข้าอีกไหมครับที่ซูมนะครับผมจะไม่ค่อยเห็นครับ Okay, as we have adopted the upward direction as the positive side, right? So we'll have 2 things like this, and from the Newton first law, right? Newton first law, we would have sigma f, right, equal 0, and yes, going up is positive, right? So T2 minus W equals 0, right? So we want to find T2, right? So T2 will simply be W, which is mg, right? M is the mass of this one, which is 15 kilogram, right? 15 kilogram, and here times G, which is 9.8. Okay, and from 9.8, you just made the multiplication, right? It's 15 times 9.8 will be 147. All right. You can also use the number 10, right, as the gravitational acceleration. So it's 147 Newton. All right. So now we finish this example, and let's talk about the next stuff in this topic. Okay. I think that everything is fine, right? Okay. An object is floating like this. Okay. In there are 2 forces, right? And at the equilibrium state, okay, when it just stay in a static form, okay, there is no movement and so on. The 2 forces are equal in magnitude and opposite in direction. So the next one, we consider the floating scenario, right, for an object or between at the water surface. Okay, some part of them will be sunk, okay, will be submerged into the water. Okay, and yes, you can see that there will be only 2 forces. Okay, there are 2 forces only. In there is nothing more, right? Because we didn't connect this mass to any hoisting cable. Okay, we don't use the hoisting cable at all. So we would วันไปแล้วอยู่ดีๆเสียงมันก็หายครับห้อง604ตอนเริ่มต้นมันเวิร์กอยู่นะครับโอเคไหม sorry for that อ่านหน่อยครับขออภัยด้วยครับปาฏิหาริย์เพิ่งเห็นแล้วก็อ่านแล้วแก้ให้แล้วนะครับเสียงมาแล้วนะครับปาฏิหาริย์ที่ซูมนะครับส่วนพวกคนอื่นอยู่ที่ช่อง Streamlab ใช่ไหมใช้โทรศัพท์ถ่ายหน้าจอ iPad ครับผมโอเคผมถอดหูฟังนะครับไม่งั้นมันจะกล้องอยู่อย่างนี้นะครับมันจะเวียนหัวนะครับโอเคthank you very much ปาฏิหาริย์นะครับโอเคyes we go ahead พูดนานแล้วเลยบริหาร30 นาทีหลายนาทีที่แล้วนะโอเคthe first example about partially submerged case is this one, right? Raf, okay. Raf นี่ชื่อเหมือนเพื่อนอดีตเพื่อนร่วมงานผมเลยนะแต่ว่า Raf มันเป็น RALF นะครับโอเคไหมอันนี้มัน Raf ที่แปลว่าแพรเพื่ออะไรนี่โอเค Raf is constructed of wood having a density of 600 kilogram per cubic meter. Okay, as I told you, the density of any object that can float above the water is should be less than, okay, is a must, okay, is less than the density of that fluid or that water all the time, okay, otherwise this equation would not hold. When this equation doesn't hold, the object would get fully immersed into the water. Okay, they would just go to straight. They would go straight to the bottom of the container. Okay, so, but in this case, it works. Okay, the density of the raft. Okay, which is supposed to be made of wood. Okay, I just know that some kind of wood is less dense than water. But if ผมไม่รู้ภาษาอังกฤษเรียกว่าอะไรถ้าไม้สักไม้อะไรอย่างเงี้ยมันน่าจะแน่นกว่าเนื้อน้ำปะน่าจะจมเนาะแต่ถ้าเป็นไม้เบาๆครับไม้เนื้ออ่อนอ่ะมันน่าจะลอยครับโอเคไหม so that's the case for us here in the second part of the buoyant force, like the partially submerged scenario. A raft is constructed of this wood with this density, and its surface area is 50. It's 5.7 square meter. Yes, the volume is 0.6 cubic meter. The volume of the whole piece of these cubic is 0.6 cubic meter. It's not cubic, it's kind of rectangular because the sides in each dimension, the sizes in each dimension are not the same, okay, are not equal to each other. It's not cubic, but it's rectangular cubic, something like that. When the raft is placed in fresh water, as in figure 57, like this, okay, it just floats. But to the floating scenario here, they would like to know what depth H the bottom of the raft submerged. Okay, they would like to know how deep is the wood staying under water surface. Okay, let's say there is no wave, no wind at all. Okay, the water surface is smooth, is planar. Okay, and yeah, we will see how to determine H. Okay, they would like to know H, the depth of the wood under the water. Okay, yes, of course, we have to apply the result of 87, right? Which is what we just learned recently, right? 87. So let's go with that. Just from 87, from equation 87, we have rho O, right? The density of the object divided by the density of the fluid equal to the volume of the partially submerged object and the volume of that the whole volume of that object, right? นะครับผมนะครับไม่มีปัญหาอะไรนะครับที่อื่นไม่มีปัญหานะเสียงไม่ดีภาพไม่ดีอะไรยังไงโปรดบอกนะครับโปรดบอกผมได้นะครับ okay, and then let's go ahead with that. Just we have h here, right? H like this, and yes, we have this relation from partially submerged scenario, and rho O is the density of the object, right? Then density of the object is the wood, right? Density of wood, right? In yeah, rho wood is what they have provided. Density is 600 kilogram per cubic meter, right? And rho F, they say fresh water, right? Then density, the fluid right here is water, right? Density of pure water, right? Fresh water seems like a pure water, right? Pure water. And yes, law of water is 1000, okay? 1000 kilogram per cubic meter. Okay, you could see that the amount of density by water is greater than the density of wood. Okay, so in this case, the object can float, okay, above the fluid. And yeah, we have already seen everything on the left hand side. On the right hand side, VPS, right? VPS is the partially submerged volume. So the partially submerged volume is the volume under the water, right? VPS is going to be, of course, it's a kind of rectangle, right? Rectangle shape. So it's going to be A times H, right? And H is what they want, right? A is known, right? A is known, A is what we know. And V object, the last one, the volume of the object, what is that? They said, do they provide information? Okay, the volume of the left here is 0.6, okay? They say 0.6, okay, cubic meter, right? So yes, we have got that, and we would substitute everything into this expression, right? First, we go on the variable first, rho O and rho F. VPS is A and H, right? A and H divided by VO, right? And yes, you can solve this equation to H variable because this is the quantity we would like to know from this question, right? From this example, we want to know H in this scenario. So we solve this one for H. We would get rho O VO divided by rho F, density of fluid, and the area of the wood, right? So H will be density of the object, density of wood. So it's right here. We have already 600, right? 600 kilogram per cubic meter, and VO is the volume of that object, which is 0.6 cubic meter, and divided by density of the fluid, which is 1000, right? And the cross-sectional area, right, which is what they also provides 5.7, right? We move it, we substitute it into the calculator, right? Let's go to Madonna and source. Yes. What is that? ผมก็จำไม่ได้ใครจำได้บ้างเท่าไหร่นะH is 600, right, times 0.6, if I can remember properly. Just 1005.7. 1000 and 5.7, right? Okay, yes, that's the height. Okay, the height from this from 63158 63158 meter. Okay, and that's the height. Okay, the height that's stay under the water. Okay, here the depth of the water under the water, and you can also see that it's around ผมถูกหรือเปล่า 0.06, right? ถูกลอกเลขมา 0.6, 0 in front of that, so it's around 6.3, okay, centimeter. Okay, yeah, that's the depth of the wood under the water. ผมขออนุญาตเข้าห้องน้ำแป๊บนึงนะครับเดี๋ยวกลับมานะครับ Okay, let's get back to our second problem in floating scenario. Okay, it's B equal to low FVPS and T, right? Now let's move to the next page about it's a complicated, okay, more complex problem. Here we have the cube. Okay, now the size of everything, every dimension in 3 dimensions are the same, so it's a shape of cube. We have a cube of aluminum with the mass 1,000 kilogram. It's 1 ton. Okay, and it's placed in a tank. Okay, it's a big container, strong big container. It's called tank, and water is then added to the tank, and until half the cube is immersed. Okay, the water is poured into this tank, and until the half of the whole volume of this cube. Okay, and of course this one doesn't float, okay, because it's really heavy, and of course it just stay on the bottom of this tank. And what is the normal force on the cube? Okay, they would like to know the normal force due to the ground, okay, caused by the bottom of this tank or container. And that's the first scenario. Okay, that's the first scenario. And the next or the second scenario is that later they slowly pour. Okay, they slowly pour the mercury. Okay, mercury is a kind of fluid, right? But mercury is quite different from other types of liquid, because mercury is a heavy liquid. Actually, what is the reason why I say heavy? Because the density of mercury is on the same order as that given by heavy metal. Okay, like what is that? The steel, iron, copper, gold, silver, those types of metal have a large number of densities, and mercury is in the same order as that one. Okay, it's not light as water. And yeah, mercury is slowly poured into this container, and they pour in such a way that they stop pouring once they found that the normal force here doesn't happen anymore. Okay, when they found or they detect that there is no more normal force caused by the bottom, the floor of this container, they stop pouring and they leave it like that. Okay, and in the second scenario here, they want to know that how high is this mercury, what is the height of this mercury we should stop. Okay, we stop when there is no normal force. Okay, this one we still have normal force from the ground, and here we don't have the normal force by the ground, but we have a new lifting force, okay, caused by the buoyant force of the mercury. Okay, and that's the first scenario and the second scenario. All right, let's go ahead with that. In the first scenario, they want to know what is normal force here, and in the second scenario, they want to know how high, which is h. Okay, and yeah, let's solve that. We go ahead. มีอะไรเสียไหมครับผมขออภัยด้วยครับถ้าเกิด มีอะไรเสียนะครับวชิรวิทย์มานะตอนท้ายนะครับโอเคyes let's talk about scenario number 1, right? Situation 1, the first situation. Okay, they pour water into this one, right? And yeah, there will be lifting force caused by that fluid, that water, and there is, because this one is heavy, right, there is reflection on the normal force caused by the ground or the bottom of this container pointing up, right? And there will be, of course, any object on the planet should have its own weight, right? So if you draw the free body diagram, right, it's mass M, you have downward force caused by the weight, you have lifting, the first lifting force caused by the buoyant force of water, and you have another lifting force caused by the ground or the floor of that container. That's the normal force, okay, and this is what we would like to know. And let's consider the equilibrium state, okay, the static state, equilibrium state, right? We could use the Newton first law, right? Newton first law. Newton first law said that sigma f remains 0, right? So yeah, if we use or we make the reference to the typical convention, we say the positive y-axis going up will give us the positive quality, right? So here we have B pointing up, it's positive. We have N pointing up, it's also positive. We have W pointing down, right? It's going to be negative. And yes, on the right side, it's 0, right? But they want to know the normal vector, which is the second variable in this equation equality. We move B and W to the right hand side. So N will be W minus B. Okay, and let's get into the detail of each term. Okay, W of what? W of the weight caused by this aluminum piece, or a new aluminum cube. So it's W M times C, right? And yeah, M is the mass of this aluminum. They say 1,000, right? They say 1,000 times 9.8, right? 9.8, and it's 9,800 Newton, right? Here, and buoyant force is the one caused by the water, right? It's going to be, because this is the fully submerged case. It's not partially submerged case, okay? It's fully submerged case, so we have, it's partial too, right? But it's partial because the water level is not above the height of this cube. It's partially submerged. Sorry for that. Okay, B will be low F, right? Low F, and V volume or partially submerged, right? VPS, and G, right? The acceleration on Earth, on our planet. All right. So the next one is that we need to determine. Okay, low F is simply known, right? Low F is raw water, right? Or if it's raw water, it's 1,000, right? kilogram per cubic meter, right? Kilogram per cubic meter. And yes, that's the density, right? The first term is known, right? VPS is the partially submerged volume. VPS, they say they just pour the water until the water covers half the whole volume of this cube. So VPS is 1/2 of volume of the cube, aluminum cube. Okay, and do they also provide the cube? Do they provide do they say about the volume of this cube? No, nothing. So what could we do then? เราทำไงครับไม่บอกปริมาตรโอเคyes V cube. What is that? What is the value of V cube? They didn't provide. You know that V cube is the volume of the aluminum, right? Volume of aluminum. So from what you have learned before, the density rule is M by V, right? If you want to find V, the volume of the cube, volume of aluminum, right? So it's going to be V cube. V cube will be mass of this cube of aluminum divided by rho, density of what? Because this material, this cube is made of aluminum, so we have to use aluminum, the density of aluminum, right? And even they don't provide the density of the aluminum, we have to get to any place, I don't know. This one, right? Okay. If you go to the table and look for the density of aluminum, right? Where is that? This is gas, solid, concrete, aluminum here. It's 2.7 times 10 to the 3, right? It's 2,700, right? In the aluminum, right? Aluminum is 2.7. Yeah, it's the same value. Okay, both books, both tables provide the same value. It's 2,700, right? So we go ahead with it. So the from the table, we know that low aluminum is 2,700. Oh no ขนาดดื่มกาแฟแล้วมันยังเบลอนะครับโอเคไหมkilogram per cubic meter, right? You get that value, volume of the cube. And the next thing is it's time right now to determine VPS, right? VPS, partially submerged volume, is going to be half the volume of the cube, which is mass of the cube, and mass of the cube is 15 kilogram, right? Oh, no, 1,000. Okay. Let's leave it like that. Okay, we're gonna substitute later. VPS is okay, sorry. VPS is 1/2 of M cube by rho AL, right? Rho AL, and yeah, that's VPS. And what else? You know B right now, right? You know W, you know everything. It's time to compute in the normal force, right? N will be W, which is M of aluminum, M of cube, times C, right? And that's the first term, W minus B. Minus B, B is the product of rho F, rho of water, and VPS is 1/2 M cubed divided by rho AL, right? In G, okay, you can see that we have a common term, right? We have a common term MQ and G. So let's move out of the parentheses. We get M cubed times G. In open parentheses, we have something here, 1 minus 1, 1 is minus 1/2 of M, no, there is no longer M cubed is rho water, and rho aluminum, okay, rho of aluminum. Now it's time to move, substitute everything into this expression. MQ is 1000 times C, which is 9.8. And then 1 minus 1/2. Law of water is 1000. Law of aluminum is, what is that? 2.7 is 2700 kilogram per cubic meter. And you have here 9,800, right? 9,800. And yes, it's 5400 minus 1000, okay, divided by 5477, like that. And please don't remember, and don't forget, we have, okay, we don't forget, we didn't forget T, it's right there, right? So if you use your hand, right, it's gonna be, if you use your hand, it's gonna be 9, 8, and 54, right? And it's here 4400, okay? 9, 8, 55, 54. And let's use the calculator. ขออนุญาตคำนวณที่อื่นครับเพื่อว่าสลับหน้าไปมาแล้วมันยังงงใช้คอมพิวเตอร์นะครับอาจจะไม่อยู่ในจอนะครับแต่ถ้าใครอยู่ที่อีกช่องหนึ่งครับอาจจะเห็นว่าผมคำนวณเนี่ย98 oh it's 98 divided by 54 times 4400. Okay, yeah, it's 7985. It's equal to 7985.1845919. Okay, up to you. And yes, it's in Newton, right? Because this is the normal force. It's a kind of force, right? It's not M. This is N. Normal force is like this. That's it. First answer to the first sub question. Let's talk about the second scenario, the situation number 2. Okay, the second scenario, the second situation. Let's talk about the second situation. What is that? So they pour the mercury, right, into the water in until there is no normal force at all, and it's still stay in equilibrium state. There is no lifting force caused by the ground or the bottom of the container, but rather we have instead the lifting force caused by the mercury, right? We use the buoyant force by the buoyant force caused by mercury to lift this one up, and we just pour the mercury until we don't detect or find the normal force anymore. So if you draw the free body diagram of this object, of course, you would have the first layer of water, right? First layer, and you have another layer of something toxic, mercury. Okay, this is mercury, and let's say this is H2O, right? This is Hg, right? And here is the ground, the floor of the container. Okay, the floor. Okay, let's draw the free body diagram. Of course, we have weight, right? W mg, right? We have lifting force caused by the first liquid, which is H2O, right? B H2O, B water, and we have another pointing up to, right? The lifting force caused by mercury, right? Hg, right? And yeah, it's again stay in equilibrium state. Equilibrium status, and we can use the Newton first law the same way, right? Newton's first law, and the result is sigma f equals 0. All right, sigma f equals 0, and we use the typical convention, right? And yeah, past and so on, right? You follow this, and you would find at the end that the normal force BHG. Okay, you form up this equation and you compare it to the previous scenario. BHG is going to be normal, equal to normal force. It would be equal to the normal force as before, right? But let's get into the detail of the lifting force, the buoyant force caused by mercury. So what they want to know is the height here. The height here of the layer of mercury, right? Hg. What is this value? Okay. If we go into the detail, BHG is the low F, right? Low of liquid, low of Hg, time V, right? V partially submerged, and times C, right? Times C. So we need to determine, okay, rho Hg is available from the table. We could find it easily. It's not a big deal, right? But we would rather pay attention to VPS, partially submerged. Okay, partially submerged means the volume of this object inside the liquid. Okay, that portion. So the mercury will be the object will be surrounded by this mercury by H, right? The height H, and volume is the product of the cross-sectional area times H of Hg, right? And they say that the aluminum here has a shape of cube, right? It has a cubic shape. So I don't know, VPS is like this right now. พอมันล้าก็ลืมนะครับลืมจากสอน604อย่างเนียนเดียวVPS is like this AHG and A is not VPS it's like that AHG they want to know H right so we substitute we didn't know yet the cross-sectional area okay area of the cube and what is that okay area of the cube let's talk about the shape of the cube any cubic shape is somehow it is right you would have this one here x okay we don't know the size of this cube yet this is one here x and we also have the height as x right and the volume of the aluminum of the cube will be x let's just to the 3 right with the power of 3 so we know v cube but we don't know a cube right but of course if you take a look at a cube here a cube is the product between the width and the length right width and length is x square okay x square is like that but what is that vq we would like to know vq right we want to know vq aq is x square and vq is x with the power of 3 so what is the relation between a cube and v cube but of course you would find that a cube is the is x3 with the power of 2 by 3 right you just place it again by the power of 2 by 3 you get x square like this okay it's the area of the cube but what is x with the power of 3 x this is 2 3 that's the v cube right so a cube is v cube with the power of 2 by 3 okay and do we know v cube in this scenario do we know the volume of the cube in this scenario they didn't provide the information of the cube volume at all right they didn't say something like that they just say they have 1,000 kilogram of the aluminum right so we keep so let's go further we are now trying to find vq what is that but as you know before right density is rho of that object divided by equal mass of that object divided by its volume right if you want to find vq you move v to the left hand side move low to the right hand side vq will be m right m mass of what the mass of this aluminum right mass of this object which is 1,000 mass of aluminum divided by density of aluminum too right mass of aluminum is 1,000 kilogram divided by the density of aluminum any of you who knows density of aluminum let's get to the density table we have two tables of density where is aluminum is right here it's 2,700 right as we have seen before so this one is 2,700 it's actually 10 by 27 or approximately 10 by 27 0.41 6666 blah 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 okay cubic meter. All right, but it's not our target. We want to know. Oh, no. We want to know a cube, right? So a cube, the cross-sectional area of the cube here, it will be 10 by 27 with the power of 2 by 3, and we would get that right from the calculator again. Oh no, it's not the same. I'm wrong. It's 73 here. 0.73. 73. Oh, 37. I'm stupid. 0.37. Yeah, it's already correct. Yes. And if you put it into the calculator for this one, right? This expression, put it into the calculator, you get 10 by 27 with a power of 2 by 3. Oh, ภาษาไทยมาได้ This is 2 by 3. Yes, it's 0.157. ปากกา 0.17. Approximation too, right? 0.5157, and oh no, why do we have that? And 3, 2, and it's a square meter, right? The area unit is square meter. We get a cube right now, right? This is a cube. VPS is known, right? Let's get back to this expression. BHG is equal to, is the same amount of the normal force. We know rho HG, right? It's 2,700. VPS is the product between a cube and HG with the height of the mercury. Height of the mercury here. Okay. Yeah, height of the mercury, and yeah, we would be able right now. N, right? N on the left is rho HG, and V, right? VPS is the volume, and it's equal to a cube, and H, the height of the second liquid, HG, by mercury, and G at the end, right? Now we're going to need to solve this equation for the destination, the variable, the HG, right? The height of the mercury. HG is N. Rho HG and a cube and T, right? So you get the normal force from the previous sub question 7985.18. Okay, approximation. And rho HG is 2,700. And AQ is what we have just got before recently with 0.51, right? 0.516, and T is 9.8, right? And we will be able to solve that to get the heights of the mercury, the second fluid in. Right, where is October? October N is like that, right? It is this value, and no, density of what? Density of the density of mercury. Okay, mercury has the density greater than aluminum. It's not 27, it's 13 times 13 times 10 to the 3. Okay, or 13.6. I'm sorry for that, missing one decimal precision. 13.6. Yeah, and a cube is 0.5157 or 516. Okay, in J is 9.8. You get height, the depth, the thickness of the mercury layer as 0.011617 meter, right? And in appropriate units, if it's difficult to understand, it's actually equal to 1.2 centimeter approximation. Okay, approximately. We get the solution like that. Okay, the answer to the second sub question, like 1.2 centimeter. All right, we need to quit the lecture right now, right? Because we have to stop at 11:50. It's 11:32 right now. จริงๆห้อง64เขาขึ้นพวก ideal fluid แล้วแต่ว่าขึ้นหน่อยแล้วกันนะครับ Okay. Yes, in the next topic, we have finished the story about fluid pressure and buoyant force. Okay, buoyant force in the first scenario fully immersed into the liquid, and the second case partially submerged into the liquid, right? So the next topic, okay, is ideal fluid. We're going to go further and further to ideal fluid, and then continuity equation, and then Bernoulli equation. Okay, how the fluid move. Okay, you have seen already the fluid staying in a constant way. Okay, the next one is the dynamic, the movement of the fluid. It's a little bit more complicated, but it's not beyond your ability. Okay, here now the fluid is moving, and if you have a visit at any dam, okay, not only in Kanchanaburi, this dam is called Meklong Dam. Okay, and if you take a look at the water surface, it's hardly it's hardly predictable. Okay, you cannot simply predict the surface of the shape of the water surface here, okay, because it involves so many factors, the flow from different parts in this water gates, right? So yeah, in the realistic case, the behavior of the fluid is very complicated. So we cannot get into the detail. Okay, it's beyond human ability right now at the moment. Okay, maybe in 200 years later, I have passed away, or I'm died already. Yeah, here is the whirling, is the flame. Okay, with swirling shape. Okay, it depends on many things: the pressure, the wind in that environment. Okay, this is the realistic shape of the fluid. Okay, why do you say this is the fluid? Because the flame is a kind of burning gas, right? And gas belongs to fluid. Okay, fluid and liquid are known as fluid, right? So in the realistic case of the fluid movement, we cannot predict the shape at all. It's very, very hard to predict the shape of the movement of that fluid. Okay, we are going to consider ideal fluids. Okay, we will talk about that on Wednesday, and I hope that we could see each other in the online manner, right? You think we can meet on Wednesday in the online manner นะครับคือวันพุธเรียนที่แบบออนไลน์ได้จริงหรือเปล่าคุณถามดร.โชคนะครับเฮนรี่พัสิทธิ์ช่วยถามดร.โชคหรือว่าใครก็ได้นะที่เป็นตัวแทนถามว่าเพราะว่าเขามีจดหมายมานะผมส่งให้คุณดูแล้วนะว่าเขาบอกห้อง6ออนไลน์จริงม.6ออนไลน์จริงก็เป็นงั้นได้ก็ดีนะเดี๋ยวผมเช็คกับดร.โชคอีกทีนะครับเพราะว่านโยบายโรงเรียนมาเขาไม่ได้พูดยกไม่ว่าไงก็ตามก็Okay, let's talk about our homework. Okay, the homework is something about, of course, what we have just finished. The buoyant force. Okay, the lifting force caused by the fluids. Okay, the material is immersed into the liquid or the fluid, right? And we're gonna see it into cases, right? Fully submerged and partially submerged. Okay, choose any scenario that you could do. Okay, and make the high precision in computation. Okay, because I use computer. And นะครับการบ้านก็คือให้เลือกปัญหานะครับของการเอาวัตถุจุ่มลงในของเหลวนะครับในน้ำหรืออะไรก็ได้เป็นชนิดใดก็ได้ที่เป็นของเหลวนะครับแล้วก็ให้หาเรื่องที่มันเกี่ยวกับแรงลอยตัวนะครับก็คือ buoyant force หรือ lifting force นั่นเองครับ1ข้อเหมือนเดิมนะครับส่งวันศุกร์หน้าเดี๋ยวผม create นะครับใครไม่ได้พิมพ์ชื่อกดพิมพ์ชื่อเดี๋ยวผม capture หน้าจอส่งให้พบกันใครส่งการบ้านเกิน9 โมงจะขึ้นเลนนะครับคุณได้สิทธิ์ 0.75 นะครับถ้าผิดก็ 0.5 นะครับโอเคไหมเพราะว่าสติ๊กหน่อยแล้วกันเทอมที่แล้วปล่อยเกรดอย่างรู้เลยนะครับคะแนนง่ายมากโอเค see you on next Wednesday right บ๊ายบายครับสวัสดีครับ if you have any question just let me know raise your hand but not many of you are in the class right now okay I don't know what you are doing only 3 people in the YouTube channel one person ปฏิหารนะครับ in the Zoom channel right บ๊ายบายครับสวัสดีครับ Just want to